Hello and welcome everyone. Today is the day we have been waiting for about a year. So from designing the project on paper to actually making it to reality, we have done it. So in our project, we have made a research through surveys, we have made multiple prototypes and made improvisations along the way.
Our journey began by first developing the main logic for our code to aid software development and avoid risk of investment for a single board computer. We first made the first prototype using Arduino, but the processing was done using laptop's computation.
As Swaroop mentioned, previously it required a laptop to be connected to it all the time, but we wanted our product to be a standalone unit. So we finally shifted to a single board computer, that is Raspberry Pi, and then we moved on to the product design and development, and we made our design from prototype to an actual product.
So this is the product, the gesture-based home automation, which we are calling as Wave. So let's wave off into its working. Okay, so now I'll be explaining the working and logic of the product with the help of a flowchart. So basically there are two key components which we have used in the product, that is OpenCV and MediaPipe. So what exactly are they? OpenCV is your computer vision library which helps you capture the image. So for example, I'm showing my palm here to the camera module in front of me. The capturing of the image itself is done with the help of computer vision, that is your OpenCV. And MediaPipe is a set of pre-trained machine learning algorithms which is devised by Google itself, so it's pretty much accurate. So we have extracted the hand gestures file from MediaPipe for our product. I will now explain the working of the product with the help of a flowchart. So basically this is the first step where we capture the image with the help of OpenCV. Okay, then moving on to step 2. Here the image format is converted. What is that? So OpenCV basically captures image in BGR format, but MediaPipe does not understand BGR format. It only understands RGB format. So for MediaPipe to understand the format of the file, it needs to be converted from BGR to RGB. So this is done in step 2. Then we move on to step 3. In step 3, the MediaPipe is used to plot hand gestures. So MediaPipe plots a set of points on your hands which is used for hand gesture recognition. And moving on from step 3 to step 4, here we use the counting logic. So what is the counting logic? So MediaPipe needs to recognize which gesture is currently being done by the user. So it uses the distance between the points to calculate the correct appropriate gesture which is being done by the user. So moving on from step 4 to step 5, this is a very crucial part of the product itself. So it prevents any mishaps from happening. What can be the mishaps? For example, if you're trying to ask someone to get you 2 books, but the camera will not understand whether you're telling the product or someone else. So for the camera to understand, we have put in a basic initial condition. So it needs to recognize a fist condition before you enter your gesture for recognition. So basically you have to show your fist to the camera module for about 3 seconds, after which you are entitled to show the gesture. If you don't enter the gesture within 5 seconds, then the machine will go back to its scanning state. So this is used to prevent any mishaps from happening. So after the initial condition is verified, the working then moves on to step number 6. So here, after the initial condition is satisfied, you can then show your gesture. Suppose I am showing gesture 2. So the appropriate action with respect to the gesture 2 will be performed. For example, I have my fan registered as gesture number 2. So it will turn on the fan with respect to the gesture I am performing. Then moving on from step 6 to step 7. Now here we have put in a flag condition. For example, let's consider my fan again. I have my fan already on, so I cannot turn it on again. So we have a flag condition which determines whether the action to be performed on the device is in ready state or not. That means whether the device is on or is it off. So if it's off, then it turns on, and if it's on, then it turns off. And then we move on to next step, that is moving back to step number 4. That is, it keeps scanning the room until it recognizes a basic initial condition. And this process is iterative, and it keeps going on in the order which I've just explained. Thank you.
Moving on to the implementation of prototype 1. As mentioned before, investing a huge amount of money, was very risky because we weren't sure which single board computer would satisfy our requirements. At the same time, we weren't sure which would be very cost effective for us. So at that moment, we were very indecisive which single board computer to go for. Instead, we decided to just write our code for now, and we can switch to a single board computer for a prototype 2. So that's what we did. So talking about software side of prototype 1, we wrote our code in Python. We use three major libraries. First being OpenCV. So OpenCV is used for capturing webcam feed from the webcam, and webcam frames are in BGR format. So we also needed to convert BGR format to RGB format as well. Second library which we used for prototype 1 was Pyfermata. So Pyfermata is used for Arduino. So we wanted prototype 1 to demonstrate 220 volts devices as well, AC devices as well, which cannot be demonstrated using just laptop or desktop as well. So we were forced to use a microcontroller as well. So for microcontroller we use Arduino Uno, and Pyfermata is a library which is used to write Python codes for Arduino devices. And third library being our main library, which is MediaPipe. MediaPipe library contains various pre-trained models, among which is hand plotting model, which we are using in our code. So hand plotting model is used to plot hand points on a on the webcam frame. These hand points contain the coordinates. So these coordinates of each hand points are stored in landmark variable, and this landmark variable is used in our main logic. So as mentioned by Aditya, using this landmark variable, we calculate distance between these 2 points and divide it by 2 to get the threshold value. And using this threshold value, we compare if the finger is up or not, and accordingly we get the number of fingers which are up. The advantage of counting this threshold value is that the threshold value is variable as well. So if the user or the subject is near or far away from the webcam, the threshold value also changes with the user's position from the webcam, and the number of fingers which are up will be always accurate. Coming to the hardware side of the prototype 1, the processing is done on laptop. For triggering we are using microcontroller, and we needed to switch. So Arduino GPIO pins gives a 5 volts output, whereas we wanted 220 AC volts devices to get triggered, which is not possible just by using Arduino. We needed to convert it the 5 volts to 220 AC volts, for which we use the relay. So when relay gets input from Arduino, 5 volts input from Arduino, it switches it to 220 volts AC to the devices so that the device gets turned on. At the same time, as you can see, we have also implemented we integrated an LED unit, so the user can also get to know when to show the gesture to the webcam and to trigger the socket. And so now we have one relay and then Arduino. So what we did is we stacked them on top of each other so that we can get a compact size of our prototype 1. Coming to the demonstration of our project, so as you can see, at socket 3 my charger is connected, and my charger is connected to my phone. Currently it's not charging, so on my laptop, on the right hand side the VS Code is running, and on left hand side my webcam feed is there. On webcam feed you can clearly see my hands are getting plotted by using the MediaPipe's hand plotting library. So when I show 3 fingers as the gesture, the code detects that 3 fingers are up, and accordingly the socket 3 gets triggered, and as you can see the phone starts charging. Vice versa, if again I show 3 fingers to the code detects that 3 fingers are up, and the charging gets stopped. The only drawback which we faced from prototype 1 is that we always wanted a prototype to have its own processing unit, which clearly prototype 1 didn't have. The processing is done on laptop, and laptop sends a signal to Arduino, which triggers the relay to trigger the device, and so on. So this is the only drawback which we face from prototype 1, which will be overcome by prototype 2, which will be discussed by Prabjot in few minutes. So moving to prototype 2.
So moving on to the next phase of our product, that is the actual product development. As discussed by Swaroop, the main drawback of our previous prototype was the fact that it always required a laptop to be connected to it. And that is not something that we would ideally want in a product. So it was high time for us to shift on a single board computer. We finally got ourselves a Raspberry Pi. So there are two parts that I would break this phase into. The one would be the software aspect of it, in which we move our script to the Raspberry Pi and optimize it for that. We also made a server for it so that we could control the device on using a web page. And the other aspect would be the actual fabrication. So first I would be talking about the software aspect of this phase. So we had the script running on a standard PC. We tried to shift it onto a Raspberry Pi, but that did not straight up work because of the architectural difference between the standard PC and a Raspberry Pi. The Raspberry Pi just couldn't handle that script, so we had to further refine it down by. So basically, we were using the MediaPipe library, and out of the MediaPipe library, we now only imported the classes that we required for the hand gesture recognition, and instead of importing the entire library, that further refined our code by a lot. We could get it finally run on the Raspberry Pi. No, obviously not as smooth as a standard PC, which would run the script at around 30 frames per second. A Raspberry Pi would run it at 6 to 7 frames per second, but that was enough for a program to work and the product to work. We also deployed our script onto a Flask server so that we could access this over the web via a web page, which would show the live feed of the camera so that it could be also used as a CCTV. Other than that, we also provided buttons for us to be able to control the sockets over the web page as well. So now talk about the fabrication part of it. So this is the part where I actually show you what we made. So this is how it actually looks. The circuitry inside, that is the Raspberry Pi, which triggers the relay, and then the sockets, all of this. So onto how it's made physically, there are three primary parts to the fabrication of it. One is the gray part, that is made out of PVC. It's made out of PVC pipes. So basically I took a PVC pipe, I cut a portion of it, heated it with a heat gun to make it straight. Now once it was ready, I molded into this. After that, this next part is the top part, which is made up of acrylic. I got it laser cutted. I would also be showing you the files for it. So this is the file that I used for laser cutting the acrylic. So there are, as you can see, there are two parts to it. There's one that is made up of transparent acrylic, which is this part of it, and the other half is this, that is the made out of white acrylic. So basically, for these to fit in with each other perfectly, I also had to make a lot of 3D printed files. I would also be showing you those. So this is my file for the 3D printed parts that I made. So this is for the white acrylic part to fix onto the gray PVC part. This is for the sockets to fit in perfectly onto the acrylic board, and this lip is for the white acrylic to fit on the transparent acrylic.
So moving on to the actual demonstration of our project, as general home automation devices generally require to be connected and could not be moved around easily, that is one feedback that we got in our survey. So we wanted to be a basic plug and play device. So for it to function, you just plug it in on a regular socket, switch it on, connect it to a webcam via a USB port. So ideally you would want to place your webcam at a place where you could see your entire room around. So I have placed it on my monitor because this is a place where my entire room gets covered from. So I'll now plug it, switch it on via the power button that is there, and wait for it to initialize. Also for demonstration purposes, I would put this bulb on so that you could see when the light is getting switched via the hand gestures. So this is how the website looks. So you could control the device from this as well. Suppose I press socket 2, the light is placed on the second socket, so that would switch. and similarly by pressing it again you could switch it off. We have also integrated RGB LEDs onto it, which stays this bluish white in the default state, but as soon as I show a gesture onto it, so for now example I would be showing a hand gesture to it, the light turning green indicates that the initial condition, that is a close fist, has been detected by our device. The green light turning red indicates that the initial condition has been satisfied and now the device is actually looking for the hand gesture. We have also integrated buzzers that allow the user to know about the states. I have tested it out for the entire range of my room, so I would go at I can literally sit on my bed and control it quite easily. So yeah, it works perfectly.
We have now reached the end of our project demonstration. Who knew you could one day control your lights with just a wave?